Now I'd like to talk about homework 3B, problem number 2. This is a retrospective. Okay, I try to explain a few more details in addition to the solutions that you have. Okay, please print the solutions, and I explain things based on this solution. If we look at this is a unit hydrograph problem. The first one is talking about mass balance. Okay, we need to realize that these discharges are in response to 1 centimeters of rainfall. And you see that in the unit. It says per centimeters. So if you are given 1 centimeters of rainfall excess, that's the amount of water that's available in that basin, they will become discharge. Right? Therefore, there is implicitly a mass balance equation, which is if you have 1 centimeters of rainfall times the area of the basin, that would be equal to the amount of water that flows out, and that is the summation of these discharges times delta T. Okay, therefore, when we solve the problem, and we have the area is equal to 1.5 plus 3.5 plus blah 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 plus 0.5 plus 0, and all these numbers, you sum them up, you times the delta T here, which is 5 minutes. The 5 minute comes from their intervals, their differences. Okay, so that's 5 minutes times 60 seconds per minute. All right, and that is over 1 centimeters. Okay, over 1 centimeters. Right, and therefore, as a result, you see that in the solution we get it produces 8,100 meters squared per 1 centimeter of rainfall, and we consider that unit, we get 810,000 square meters. Okay, 1,000 square meters. All right. So some of you might have this question: why do you do 5 minute instead of this 15 minute? What is their relationship? In fact, there's no relationship. Okay, what this 15 minute is trying to tell you is that rainfall duration is 15 minutes. However, it doesn't matter what the duration is, whether it's a 15 minute or 5 minute. Okay, eventually the numbers that is described here is in response to that 1 centimeters of rainfall. Okay, it doesn't matter from a mass balance point of view. It doesn't matter whether that rainfall falled in 50 minutes or falled in 10 minutes or whatever. So that duration doesn't matter. What matters is this interval. Okay, an interval. Imagine that you have a 6 meters cubed per second discharge that lasted 5 minutes, from 15 to 20 minutes. Okay, from 15 to 20 minutes. Okay, let's go this way. Let's go from 10 to 15 minutes. This 5 minutes, we take this number and multiply by that time duration, we get how much water mass or volume come out of the basin. Okay, that's where the 5 minute is coming from. Some other solutions that you might find online actually does a average. Okay, for example, between 5 and 10 minutes, he take 1.5 plus 3.5 and average it, and come up with a solution and multiply this by 5 minutes. That gives you the volume of water that outflowed between 5 and 10 minutes, and that is okay. And what you realize is that if you do that, the solution is very close to what we get here. And as an extension, what he did here with this averaging scheme is actually called trapezoidal scheme. However, we do not require that. So this solution is sufficient. Okay, this solution is sufficient. And the numbers are pretty close. Okay, all right. Let's talk about the unit hydrograph. Problem B here. We give you the rainfall time series, which these are given in 15-minute time intervals. And first thing you got to realize that here we set cumulative rainfall excess, and it's given in millimeters. Therefore, the rainfall excess that happened in the first 50 minutes is 10 millimeters, which is 1 centimeters. Right? Why? Because you have to convert this to match with that per centimeter unit. So that gives you 1 centimeters. Okay. Sorry. Here I should write it here. in order to not to confuse you. So this 1 centimeter occurred between 0 and 15 minutes. Between 15 and 30 minutes, there is a difference of 20. Okay, that 30 means from 0 to 30, you have 30 millimeters of rainfall. Okay, then between 15 and 30, you really have 2 centimeters. Okay, similarly, between 30 and 45, here we write 0.5 millimeters. Okay, so now it comes to doing the first step of unit hydrograph. That is called scale. For the first time interval, you have 1 centimeters of rainfall, and all this discharge again is given in response to 1 centimeters of rainfall. Therefore, you just directly copy this number. Very simple. Just directly copy all this number. Okay, 0.5 here, 0 there. However, the second interval has 2 centimeters, and we assume a linear model. We assume a linear model. If 1 centimeter gives you this much, then 2 centimeters give you twice as much. Okay, so the scale step, okay, this first scale step is talking about multiplying this unit hydrograph with the rainfall excess, okay, in the same unit. So here we have 0 and 3 and 7 and 12, which is 6 times 2, you get 12, and you do this all the time until end. This guy has multiplied by 2, you get 1 and 0. Right? So the third, you have 0.5. Okay, 0.5. So these numbers, you divide them by 2 and lay them down here. So this is the scale step. So 0.75, 1.75, 3, blah 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 blah. That this guy is 0.25, 0. Okay. So that is the unit hydrograph after the first step, scale. The second step is lag, and this is the step where most people are confused. This is I can give you guys a trick. Just look for the origin. Okay, look for the origin. What do I mean the origin? That means the exact moment when this rainfall excess fall. Okay, what is this exact moment? So for the first for the first minute, for the first 15 minutes, the exact moment is the same as what is indicated in the unit hydrograph. That is 0. That's exactly when this rainfall falls. Therefore, the lag step, you don't have to do anything for the lag step. Okay, you just directly copy it. Just directly copy it. For the second step, okay, you have to think about this 2 centimeters. This 2 centimeters is accumulated between the 15th and 30th minute. Okay, between these two, you got 2 centimeters. So what is exactly the moment when this 2 centimeters of rainfall begins to fall? And the answer is 15 minutes, right? That's exactly when it's about to fall but has not yet fallen already. Therefore, that origin 0, we move the origin 0 to 15 minutes. Okay, so here this is 15 minutes. This lies down to 15 minutes. So that's when your 0 starts. Okay, so everything else is like a caterpillar. You take the head of the caterpillar, you take the tail of the caterpillar, you move it here. Okay? Okay, don't abuse animals, but this is what you do. You take this part, you move it here. And so you have a 0 directly underneath the 15, and you have 3 under the 20, you have 7 under the 25, everything else just follows. Okay? Whoops, wait, okay, guys, forgive me. This vertical axis might have confused you. You have 15 here, okay? You have 30 here, 45 here. Sorry. So this is 15. You have 30. So this between 15 and 30, between these 15 and 30, the 0 started exactly on 15. Okay, so that's 15. That's number 0. Okay, that's number 0. Then the rest of this is just take this piece and move it here. Now let's talk about this last 0.5 centimeters. When exactly did it start to fall? It's accumulated between 30th and 45th minute, 45th minute. Okay, so the answer is that it starts to fall on the 30th minute. That's the 0. That's the origin. All right, so look for the 30. That's here. So this is when you have a 0. Okay, the next minute, 30, the next mark, 35, you have this 0.75. Okay, then 1.75, blah, 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 blah. And that's why you see it's lagged like that in the solution. That's why you see it's lagged like that in the solution. Okay, when with our whoops, might have no, sorry, this is the wrong. That was the wrong one. I think this is the right one. That's why you see here. This guy is they have a 0 on the 15th minute, and for the third guy, which start at 30, you have a 0 underneath the 30, and everything else just follows like a caterpillar. Okay, like a caterpillar. All right. Then you add up every guy together. You add up all of them. Okay, vertically. So here 1.1, 1.5. 3.5, and then you don't have anything to add until this guy 20s. You have a 5.5 here, but a 3 here. Okay, then you get a total is 8.5. Okay, base flow then is added after you adding together the surface flow hydrograph. Okay, surface flow hydrograph. Don't add it to each one of them. Just add to the final accumulated surface flow hydrograph. All right. So that's as much as I would like to say for problem 2. And you have the solution. Please look at that if you want to really understand this problem. Thank you.